Welcome to Ask AI, the podcast that brings you insightful interviews and news from the world of Canadian artificial intelligence. This episode is sponsored by Microsoft Canada. Microsoft is committed to building trusted and responsible AI systems. To learn more, go to microsoft.com/AI and check out their free AI business school to start building intelligence into your solutions today. We're also sponsored by Cinchi, the global leader in data fabric technology. Visit Cinchi.com to learn how to eliminate integration and turbocharge your AI transformation.
Hello to all of our artificial intelligence enthusiasts, and welcome to the next season of the Ask AI podcast. Today, we're welcoming Bin Liu to the show, and I'm really excited to have him on as our first guest for this new season. So Bin is the CEO and co-founder of Immersive, which is a Toronto-based manufacturer of wearable technology, and they specifically support people living with vision loss. So Bin, welcome to the Ask AI podcast.
Hi there. Yeah, thanks so much for having me.
Oh, you're so welcome. So as I mentioned in our introduction, your company actually works with people who navigate life with the incredible challenges that are posed by vision loss. And I know that both you and your co-founder, Arjun Mali, you have a personal connection with this affliction. Could you tell me a bit more about that?
Sure. This whole thing kind of started from a phone call I had with my mom. So my dad actually has glaucoma himself. As you know, there's no cure for glaucoma, so he will just eventually be losing his vision gradually. He can only control it. He's probably the most stubborn person I know. So kind of having an argument with my mom on the fact that my dad really shouldn't be driving at night anymore. So I started to look for things that he could potentially use later in life, but I ended up finding nothing. And as an engineer, first thought was, why not start building stuff that he can later use? So I called up Arjun, who was my first choice as a business partner. We've known each other for a long time since university. And it just happens that his family has a lot of tie-ins with the vision impaired community as well. Starting from his grandmother, they've been supporting a blind orphanage in India for decades now. So he was really personally involved, and he jumped on the idea straight away.
Wow, that's incredible. And how had you two worked together before?
So we didn't actually work together before. It's more like we played poker before during university.
That's what makes great co-founder relationships there.
Yeah, it makes great conversations to understand someone else.
Very nice. Yeah, you know each other's talents, right? Yeah, interested to know how you two got started specifically. Like, how did you go about assessing the problem that you wanted to solve?
Sure. It sort of goes in two stages. The company has been started for a while, right? We started the company in 2014. At the time, we had very little knowledge. Both of us just graduated from university. We're lucky enough that we had the opportunity to join University of Toronto-based incubator called Impact Center. Kind of went through a month-long crash course on what it actually means and how do you actually start a company. And then we started just talking to a lot of people. We interviewed hundreds of people here in Toronto and hundreds of people in India and figured out the biggest problems on a day-to-day basis for people living with vision impairments or head-level obstacle detection, because canes go under a lot of things. And while guide dogs are trained to look up as well, it's just not natural for them to look above their eye level. So there are some issues there as well. Second thing was actually navigation, just because for someone that's vision impaired, getting instructions, just picture them getting instructions like, go 500 meters and turn right? It's kind of not very useful because everything in between the 500 meters could potentially impact their travel. And the last thing was detecting elevation changes. We had no idea how to solve detecting elevation changes, and the navigation problem was too big of a challenge in 2014. We tackled that now with Mapping Hood, but that's why we started the first project to tackle a smaller thing of detecting obstacles above the waist level.
That's incredible. I suppose it's tangential or fairly different, but I remember looking at I was writing a brief article about like the Roomba, for example, and how they actually use mapping technology to move around a room, and even just looking at, very low obstacles and how to respond to those. And I've always found that fascinating. I mean, we've often got our heads up here, I suppose, but then a lot of the challenges, even just moving around, it starts pretty low. And it starts with some of the basic facial recognition. And I'm interested, could you detail more of it? So what does Immersive solution actually look like? Like, how does it work?
Sure. I'll describe mostly what we're working on today, but just briefly touching on what we did first. It was a very quick thing at engineering background. So we just built a small sensor that was wearable. Someone with vision impairment can attach it to the collar of their shirt or the lapel of the jacket, and it uses ultrasound, detects anything in their direct path, and then based on distance, it just gives them vibration feedback. Just a complementary tool to a guide dog or a cane. We launched that generated some revenue, and then that made us start to think, okay, we need to tackle bigger problems, right? And we need to figure out a way to get solutions in this community with even lower cost, which led to Mapping It. And how this whole thing started was that we actually met with Microsoft a lot at a conference called CSUN, which is the largest vision impairment or like vision assisted technology in North America. Over multiple years, we met them there. And then one of the years, like we built a relationship over time through conversations. And then one of the years, we kind of started pitching the idea of why aren't we doing something for navigation, right? Because before then, it was too big of a challenge for us technically. After speaking with them and hearing about a program called AI for Accessibility, we sort of took the leap and we applied for that. And we were lucky enough to get some sort of launch funding from AI for Accessibility, which gave us the freedom to actually increase our team size and start working on this starting in 2019. And what the navigation solution really is, in short, we could talk about it for hours, but a shorter version is, a shorter version is we're focusing on a few problems. So 3 problems mainly. The first problem is that navigation apps or the navigation systems we're used to today are all built for cars. And what that means is that the things that are calculated for or accounted for when your routes are generated are only car related. So things like you can always see the options like avoid toll roads, highway. It helps you avoid turn restrictions, one-way streets. It knows the street signs. But pedestrians don't walk on the actual road systems, right? We walk on sideways, and none of these things really matter to us. And there's a lot of data on sidewalks. Anything that's physical in walkable spaces, things that you can see, touch, or feel, those things aren't fully registered in existing databases, and those things aren't being calculated in routing engines. So we went ahead and started building a custom routing algorithm that can account for more of these things to solve the first problem. And for the data problem, we are actually compiling data through open sources like Open Data Toronto, OpenStreetMaps, as well as any other open data sources that's more up to date, and then putting them in one place and then using that data to fuel our routing engine. And then moving on to the third problem we're trying to solve is that every pedestrian is different. And even within the vision impaired community, people have different vision conditions, right? So like retinitis pigmentosa, so RP, like you have sort of tunnel vision. And then if you have a diabetic retinopathy, you have blind spots in your field of vision, right? And then some people lost vision on one side, some people have fully lost their vision. On top of that, they have different levels of orientation mobility skills. I have a friend who's blind from birth. He commutes all the way. It's a 1-hour commute, multiple bus changes, walking to different stations, and then finally getting to work downtown. He's completely fine with that. But then someone newly losing their vision, even getting across their neighborhood is very hard. So how do you solve a problem where everybody has a different problem? That's where the AI piece comes in. We start building a sort of user profile based on the user's actual travel behavior, like how fast do they travel, right? How high are their orientation mobility skills, or what things impact them? Do we need to reroute them around the construction site if they have a very low orientation mobility skills, or do we give them enough instructions to tell them, for example, hey, the drywall's on your right, stick to the drywalls, and then by the time you get to the corner, watch out for that pole in the middle, but then that's where the east-west crossing and the north-south crossing is, right? So those are the kind of things that get solved by the machine learning component, because every time they choose a different route and every time they travel differently from the suggested route or any behavior they have in the system, it's being accounted for by the AI. And it starts adjusting towards individuals' own capability to navigate.
Ben, one thing I think my favorite thing about interviewing you is how genuinely passionate you are about solving this problem and the details of it. I really, really admire that. A number of things in what you just said, so I just want to quickly break it down and make sure I heard that all right. So, first of all, it sounds like, Microsoft's AI for Accessibility grant, that's really that initial funding was what allowed you to propel the solution forward. Second, one of the things I heard was you're aggregating or crowdsourcing almost a combination of data from open systems, as well as ultimately building and sort of an AI-informed profile of individual users. And that's one part I wanted to dig into a little bit deeper is how are you combining those two things in the development process? So you're aggregating a number of these different sources from my understanding about objects or obstacles that people could face. Mm-hmm. And then you're also understanding a bit more about an actual individual's persona. And my understanding, like the way that they do wayfinding, the way that they walk around. How do you combine those things in the development process?
Right. So it was a bit of a challenge at the start. The data piece had to be separate away from the routing piece and building the user profile. But over time, they start to merge together. They start to connect with each other. And in the sense that for the data piece at the start, it was just a lot of work, but it was very straightforward. It's just a lot of data to mine from different open data portals, and then a lot of data to organize. And then put it in the format that we can actually put it on our own maps, right? And then for the user piece, the routing engine piece, we had to go in and change a lot of the routing algorithm from what is being used today and build our own. And then we had to create a process to pre-label the data to a certain extent and to basically say, for example, if as random as this sounds, a garbage bin, right, may have a positive impact on convenience, but depending on where it is on the sidewalk or depending on the individual garbage bin, it may have a negative impact on accessibility because it might make the sidewalk narrower if it wasn't following code, right? So all those things had to be accounted for. And then that's where we started connecting things. But once the AI started coming in, we started to realize that we haven't started doing that now. But as we move forward, a lot of these things can start to be automated. We do let users input data because sometimes the data is missing. Someone can add in a staircase or a curb that's not sloped into the system. But as time goes on, we're realizing that just through AI, you can actually start to automate a lot of these things. For example, as a first step, we're thinking, if you see a travel pattern, and you can picture this on the map system, on the navigation app, right? If you picture the GPS location of someone regularly following a straight line sidewalk, but all of a sudden one day, you're seeing a pattern where almost 90 to even 70 to 90% of the people are suddenly making a side divot of about a meter. That means something popped up, right, in that section of the sidewalk. And we can start to check with users to see what it is. But as we get more and more data, you might even be able to predict it because how many things just randomly pop up on the sidewalks, right? You can actually count that, potentially a tonight special sign from a restaurant, a small construction, or a puddle, right? Or something fell on the road. There isn't too many things. And then based on probability, you can actually start to predict things and then just simply asking users to verify them, which is easier for them to do versus asking them to tag something and then having other people verifying them.
So it sounds like to put this together in the first place, you're effectively using a supervised learning model.
So it's actually unsupervised learning on the user profile side because we don't actually know what it should be. That's the reason we can't use supervised learning. We don't really know where their end profile is going to be. And we have no idea to actually guide our processes because it's so widely varying.
Oh, what about that initial object labeling process, though?
That's still manual at the moment. You're absolutely right. When we start implementing that, will be supervised learning because we can get feedback from people through verification, right?
If I'm understanding, there's maybe two high-level different processes happening. One is how can we predict in general the kind of obstacles people are going to encounter? And the second is there's a combination of here are all the possible maybe uncertainties or elements of uncertainty. And if this thing comes up or if a number of different people are exhibiting this type of behavior, for example, if they're always avoiding this thing in the sidewalk, maybe that's a signal to the system. And then second is you almost have a ways like self-reporting where a user could verify or confirm that, yes, there is in fact a divot here or a break in the sidewalk, for example.
Yep. No, you're absolutely right. It's the two components. And we're using the second component right now through crowdsourcing, but we plan to implement that because the lower we make the friction, the better we can get real-time data on the streets.
That's fascinating. And do you want to go a little bit deeper into what specifically are you doing with AI technology when it's applied to the movement and mapping? And I'm also wondering, is there any kind of crossover in terms of that movement and mapping with computer vision or natural language, for example, in assisting your users?
Yeah, absolutely. So how we're currently using AI is going back to user profile. That's the main component we use AI on right now and unsupervised learning. And we're just building multiple feedback loops to constantly update the user's travel preference profile. So accounting for how much the users care about safety, accessibility, convenience, speed, caloric burn, all that stuff. And we are trying to add in more and more points of feedback through the user flow, through the app itself, through every single trip. So for example, when someone selects a destination on the app, and once they select getting directions for that destination, they're offered multiple options. So they're given a safest route. These are very generic. Everybody starts with a standard profile, even profile at the start. And based on their selection, if they choose the safest or if they choose the most accessible or if they choose the fastest, whatever the case is, that's first point of feedback. So now the system learns, okay, this is what the user thinks they want, right? So that moves the profile a little bit. And as the user is traveling through the trip itself, if there's any deviations from the route that was suggested to them, so say the user selected the safest, but somewhere across the trip, they took a big deviation away from the route that was actually suggested to them. And we know the route, based on the data we have, the route that we gave them was the safest. At 8 o'clock, maybe it's the most well-lit streets, lowest accident rate, all that stuff, right? and they took a divot through a darkened area, then this is a second feedback point for the system to learn, okay, it's one of two things. And there's still some manual process involved in here and in the feedback loop on our end, in the sense that we do need to verify that it's not a data issue. Because if we told them that the street is well lit and it ended up not being like all the street lamps are broken and it's all dark, it makes sense if someone deviated fully, right? So, but once we check that and we verify, yes, indeed, the data was still accurate, then the user deviated for a different reason. And the reason is most likely that they actually preferred a different type of route, maybe a more accessible route. It's just that in their selection, they didn't consider it, right? So then we can check the data on the route they actually took, and we can check every single object in there, compile that, and calculate what the sort of attribute really looks like over the route they ended up taking. And then we can readjust their user profile one more time. So that's what we're doing right now. And the main thing is we're trying to reduce the error rate of our suggestions. And we're trying to see what, through both data and the routing algorithm itself, get lower rates where people deviate from the route suggestion. But as we move forward, there's a lot of things we can do, add on top to make this process faster. Instead of people getting semi-optimal trip suggested to them within 30, 50 trips, we can maybe drop that down if we start implementing stuff like clustering. Because then based on the user's profile, we can compare to others, right? It's just a clustering comparison system, similar to how Netflix suggests movies based on others like this as well. Same thing, we can build a profile. We can mold the earlier profile faster that way. But then also going deeper, even for individuals, the route that you prefer on a Monday morning, if it's sunny and you're on your way to work, looks very different from the route you might want to take on the way to a coffee shop on a Wednesday afternoon and it is snowing, right? Because the weather conditions and things change. And also depending on external conditions and also depending on time of the week, your personal mood, things might change. So we want to further refine it so that it's not a generic profile that we say, okay, user A will always like this kind of route. That's not always the case. And in fact, in most cases, it won't be true. We want to say that user A likes this kind of routes Monday morning. And depending on the kind of weather that's outside, that profile might change. Or user A likes this kind of routes on a weekend with these given external conditions.
It's fascinating to know. So it really sounds like that persona is actually quite complex and really gets to know their behavioral patterns. Not just actual routes, but very much the type of routes, when they like to take them, how they like to take them. And so it goes quite deep, and that's becoming ever more sort of customized. Yep.
No, it's definitely a lot of fun for myself and our CTO. Just even think about the prospects of like how deep we can go on this. And I think there's a long way. We're just scratching the surface right now. But the good news is just, everything is just starting right now. I think we're collecting the right sort of data in terms of what feedback data we're getting from the users, but lots of fun, big projects coming up though.
Super exciting. So you mentioned some of the errors that do come up, but going a bit deeper into that, what are the unique challenges that you've encountered in this work?
Two big challenges, I'd say. One on the data side is just a data consistency issue, right? It's one of those things where we don't have a user base like Waze yet. So the crowdsourced component is very limited just because we're just running a closed beta in Toronto at the moment. And the data you get from open sources, you take what you can get. There isn't too much control over how recent some of these data are. A lot of them are pretty refreshed because of the Open Data Initiative, but you might get data that's like 5 years old, right? In which case, given how much construction and stuff is happening in Toronto, a lot of those things aren't accurate. And then also, because we're pulling data from multiple sources, it's quite a headache to try and combine these data sources together because you get a lot of overlaps. There are ways to automate the process of filtering them, but we're a small team and those are pretty big projects for us to do. So that's one side of things. And then the second side of things is in terms of the feedback loop on people's preferences. And I'll be very, very honest that this is the part that worries us a little bit. People are just generally too nice. I think it's the right way I'll say it. Like in a way that behavior we're observing from a lot of people as well is, we do follow up and interview people, right? And it's not always the route they imagine that you give them with these suggestions, but a lot of times they'll just go along with it. But when you interview them, you say, hey, it looks like you haven't had any issues. There was just being 0 deviations, right, from our route suggestions. And the actual response is, well, I wasn't really happy with like some of them, but you know what? It gave me a route. I just followed it. So it's, makes learning a little bit harder. So we're trying to figure out ways to optimize that.
That's fascinating. Super, super fascinating. And wondering specifically if there are any more things that sort of bias and privacy concerns, given that you actually know sort of how people are actually walking around and where they're going and navigating their own lives.
Yeah. So because we're in the beta testing stage, so with the people we are tracking, and we're not tracking everyone. It's a pilot we're running with CNIB and all the participants. We're interviewing them as part of the process, right? So not too much privacy concern right now, but it is a very sensitive subject. And based on the way we're trying to set it up for future scaling, right? Essentially, we're trying to set up in the way that really all we need access to is just the user's profile data, because that's what we need to generate the routes. Everything else can be stored behind sort of a locked door, and we can throw away the keys because we don't need to access it. It's only a single access through API, right? Where it updates the profiles, if that makes any sense. So it just depends on how you want to run the business itself. Some of the bigger companies, if your main goal is advertising down the line, you need a lot of the smaller details, right, to match up with the ad algorithms. But in our case, we can still run ads, but we can just, all we need to do is really look at your personal profile down the line, because that summarizes everything without us having to know where you've been, what you've done, and things like that.
Oh, it makes a lot of sense. And something I've been fascinated about recently is, we're going to have these wearable tools simultaneously. We've even seen, I suppose it's now canceled, but like the Sidewalks Lab project, for example. And it's like, well, could we potentially develop a environment in the future, or, a smart environment where you might only need a simple sensor and the environment itself will know enough, or will be able to tell you, and perhaps this technology won't be as necessary in certain areas of the city, for example.
I sincerely hope that's the case. And I can see it happening too, right? Like a combination of, especially with 5G coming around, a lot of these things will become possible. But a combination of like a lot of sensors placed very densely, and plus the 5G stations is going to be very dense as well. It bypasses the biggest problem we have on the navigation side, which is GPS accuracy, right? A 10-meter error for a car is not that big of a deal because you still stay on your lane. You're not going to suddenly jump across the road. But a 10-meter error for a pedestrian is a big deal because you're on the wrong side of the road, maybe taking the wrong bus, going the wrong direction. So certainly hope that's working out. But we are trying some stuff with 5G to see if we can increase the accuracy. Like, I think indoors, I have high hopes because it's a very controlled environment. And also the stakeholders are there that has the funding to put it into place, right? Outdoors, you can't expect the city to put sensors at 1,000 sensors per square kilometer kind of thing. It's just too expensive for them to do. But I think outdoors, at least in the foreseeable future, GPS will still have the main technology we depend upon. But back to your point earlier, computer vision could change that.
Yes, tell me more.
Well, I mean, it's not something we're working on, right? But it's something we've been fascinated by. And we want to add data to the platform. And a lot of people have made a lot of headways on that. For example, Mapillary, it's another company, big fan of, they have users take many photos along the streets and along different areas. And they patch that into sort of a 3D environment, right? Displaying the area. So things like that could automate how sidewalk or walkable space information is added onto the platform. And then going a little bit further, I might just be delusional here, but I can see a world where if we have enough street side or outside image data and it's kept real time, like kept recent enough, and then through computer vision, you can sort of navigate based on what image you're looking at. Kind of similar to how we navigate. We look at maps, we look at 3D, like a 2D shape of the map, or even the 3D version, whatever the case is. But that's not how humans actually navigate. We navigate through looking at landmarks and things we remember, right? If you see that big green sign next to that restaurant you always go to, that helps you orient yourself and helps you realize what part of the neighborhood you're in, even if you just suddenly drop there. And that's the first thing you see, right? So same thing with computer vision. If there's enough image data, you can sort of tell someone where they are if you can judge the distance to the landmark or that picture frame from the person's location. And then based on that, you can create relationships to where everything else is based on your angle to the reference point and from the reference point to the other location, if that makes any sense.
It does. That's incredible. And you sort of started referencing some other companies that you might, or you admire, or you might want to work with them. We love hearing stories of collaboration on this podcast and wondering, if you could tell us more about your ecosystem and what kind of organizations you do work with already.
Right. At our current stage, we work with a lot of NGOs. So the Canadian National Institute for the Blind, is a big local partner here. Spinal Cord Injury Ontario, so they work with wheelchair users. So we've been piloting with them as well. Disability Center Canada, but I think last but not least, and this is the partner that kicked off everything, this would be Microsoft AI for accessibility, because we'd still be talking about this stuff, right? If they didn't help us kick off everything. And on top of that, it's just two things, like very strong support from their ecosystem. So we get introduced to others, companies or other university researchers in similar fields. And it's just very fun and insightful exposure, because a lot of these projects you don't see, right? These are not stuff you see on the news. These are things that people are researching on 10 years before it turns into a product. And just to be able to see what people are working on, just you can draw a lot of inspiration from there. And aside from that, the structure, they're pretty hands-off on the pilot itself, but they provide a very good guideline on how to run a nice pilot, to actually get right data to verify, how well our AI is working and how do we scale from there, right?
Well, that's incredible that I think that you're able to partner with organizations like that are, for one, enabling you to get this started in the first place, but for two, you're kind of bringing the best of both, and you're complementing, right? You're complementing their user base or member base with sort of your willingness to make the tech, and they're sort of partners with you in the development process. So, I think it's incredible. It's inspiring to hear. And I'm wondering if, as part of working with those communities or even more generally with your users, any awesome stories that you want to share about how that looks in real people's lives?
General stories we hear, well, I don't know if this is the perfect example. I just personally found this very intriguing.
Go for it.
And first of all, disclaimer, because I know when you talk about crime rates and things like that, it's a sensitive subject, right? So I just want to clarify, we use Toronto police data to calculate safe routes, but we don't sort of stigmatize or classify neighborhoods. We don't say this is a bad neighborhood. That's not how we do things, which is a very sensitive subject right now. Well, instead, what we do is rather, we're just testing to see if people find this information useful. So we take the last 48 hours or the last week where crimes are registered on the police database, and then we just plot it on the map. And during routing or pre-routing, depending on their path cross with it, the user gets a sort of a little push notification just letting them know, hey, just for your own knowledge, what you do with this knowledge is up to you, right? A store got robbed here, or there was an assault in this area, but it just helps them to actually get this information in front of them. And the story came from one of the pilot users. This was someone that was visually impaired. I think during the interview, the sheer excitement of basically hearing, on the way home, that was just the highlight for her in the entire app. The fact that she always take the same route. So she didn't notice too much difference, except for social distancing. We started routing people around quieter neighborhood roads. But just the fact that on one of the trips, she was told exactly what happened, as in there was a robbery in the convenience store. I can't remember the exact crime, but that popped out, that warned her. And she was first to know in the household. That got her super excited, because usually she hears about this stuff from other people, much later on, right? I personally find that very interesting, just kind of the power of presenting data to people and how they have different reactions or different uses for it.
I think so too. I think when you actually see something become real and it goes from vision to reality, that must be really exciting for you, and actually see the impact of that and how you're helping people with such a crucial part of their lives, their ability to get around. So I wanted to ask you more generally, what's really exciting for you in AI right now? What are you looking forward to?
Well, going back to kind of...
it can be about mapping and navigation and computer vision, your favorite things.
Yeah. So, from the company's perspective, what excites me the most is just the progression we're making on computer vision and things like that, because those are things we can use ourselves, right? And especially just monitoring the autonomous car space. They are so well-funded. They have all the talent. We're just kind of waiting for them to crack through this whole thing, and then we can apply it on a pedestrian navigation level. That's super exciting for us on the business end. On the personal end, and my CTO just completely disagrees with me on this. He's more of the AI expert. I'm more of the engineer side, but I think evolutionary AI is something that always intrigues me. So I kind of just a little pet peeve. I like to follow on those things.
Evolutionary AI or the evolution of AI?
No, evolutionary AI. So basically, evolving through different generations, and actually, it's not the most efficient way of doing things, but I just personally find it fascinating.
I actually know very little about this. Do you actually mean AI as is applied to evolution, or I'm trying to understand more?
No. It's I'm probably using the terminology wrong. Again, I'm not an AI expert. Our CTO is, but evolutionary AI in the sense that, for example, you set rules or you set conditions, right? Or you set a threshold for the different generations. You start off with a random sample of generations. I'm describing this more like how people demonstrate it in the game sense. It's a lot more complicated than that. But if you picture visually, you can set up a sample of 100 little guys. And actually, you know what? I think the best example is, have you seen those demonstrations the different AI companies do, showing how they can use evolutionary AI to make a stickman learn how to walk across complex platforms, right? So that's kind of like, if you have 100 to start with, they're all moving erratically. You set the rules, and then you start cutting out the generation, and then you start crossing them over, and then you form the next generation. It's kind of like natural selection in a way, but you set the rules for natural selection for the program itself, right? For the different codes. And then as over multiple generations, it starts to converge towards the behavior you're looking for, whether it's getting out of the maze faster or doing specific tasks more efficiently.
Man, I'm so glad it's my role on this show to ask the dumb questions, because that was so interesting to learn about.
No, and trust me, like, I'm probably explaining this in the worst possible way. I'm not, like, I just enjoy reading materials on that. I'm not by any means an expert. I just find it fascinating, the methodologies there.
I'm absolutely going to go look up more about this. I quickly searched it as we were talking, and evolutionary algorithms, a generic population-based meta-heuristic optimization. Wow. I've definitely got to look more into this, but that sounds absolutely fascinating. Yeah, I mean, constantly hearing about new stuff that is absolutely on the brink or the cutting edge of what we're doing. Super fascinated to learn more about that and look up more. Any side projects that you're working on that we should know about?
The only one, it's probably too early to talk about, but
okay.
I'll just say what we're trying to do. We're trying to use some methodology with 5G to correct GPS accuracy. It's a pretty moonshot project. We're doing very experimentally right now, but so no confidence yet on whether or not it will work. But we just had some ideas on that we wanted to try.
I'm super excited to follow your next journey and learn more about that. And then last formal question for you. What's next for Immersive more broadly? Do you want to tell us about any future plans?
Sure. So, I mean, we have the beta out. We've been testing a bunch of things. The beta results are coming back, and I think we're wrapping up the pilot in September.
And do you want to just remind us again, just specifically what's in that beta?
So in the beta right now, like, we have app running in Toronto. We have all the open source data put in place. The basic unsupervised AI is there. The routing is there. So we've been testing with people over the past few months, just on their usage and getting feedback. We've been fixing a lot of bugs and fixing the UI side of things. So by September, it's kind of wrapping up the initial feedback phase through the beta and through the pilot. And after that's done, it's a few things. Like, we got to start expanding at some point, but even before expanding, the utilities there. But we wanted to adding some more useful things, not turning into a feature creep, but we wanted to test some things that can make this more useful for users. Because right now, especially during COVID, right? Like pedestrian navigation is helpful, but it's not something that's used very frequently. From a company's perspective, we need to find something that people can use more. So we are trying to find a way to make your trips more interesting by informing people not just what blocks them along the way, but also potentially what's happening with local businesses along the way, accounting for all the rules that's going on. So that's happening next. We're running an experiment with that. And then after that experiment is done, we'll start looking at expanding to other cities in Canada. And just depending really on what the COVID condition is like, that will be our basis of selection, right? Because it determines how much people are outside, or they should be outside.
Of course. And is there any way for people to get involved in that test, or have you already got enough testers? Or are you looking for more? What can people do to sort of fall in?
Oh, yeah, no, absolutely. If you're in Toronto, GTA areas in general, feel free to go to the App Store. We're available on both iOS and Android, and just look for Mapping Hood. And it's available for download to anyone. And then if you want to get involved, feel free to email us as well. Our website is www.mappinghood.com. Feel free to reach out to us, and happy to chat if you have any ideas.
Awesome. Thanks so much. We'll make sure that link is in the description when we post the podcast. Vin, just want to say thanks again so much for joining us. Vin is the CEO and co-founder of Toronto-based Immersive. You can watch a video of Immersive's technology in action in the blog post for the episode, which you can find again askai.org, which is our website. You can also see all of our past episodes, and you can sign up to our mailing list to get new episode updates and exclusive invitations to events and other forums. And of course, we can't do what we do at Ask AI without the support of our sponsors. And our sincere thanks go out to Microsoft Canada, as well as Sinchi for helping make this episode happen. Ben, thank you so much.
Thanks so much for having me. That was a fun conversation.
Awesome.
Thanks for listening to the Ask AI podcast. The executive producer was Chris McLellan. Additional production support was provided by Olena Mack and Kristen Riddell. To learn more about our webinar and chatbot projects and get information about sponsorships and volunteering, please visit our website at askai.org or email info@askai.org. Listeners can also follow us on Twitter, Facebook, and LinkedIn. Just search Ask AI.